Section 4.1, problem 5 says, Isabel Briggs Myers was a pioneer in the study of personality types. The personality types are broadly defined according to 4 main preferences. All right, so do married couples choose similar or different personality types in their mates? The following data give an indication. All right, so we've got all 4, all right, number of similar preferences. So all 4 are similar. 3 are similar. 2 are similar. 1, they have nothing in common. All right, here's the number of married couples that have each in common, right? So there's 34 couples that have all 4 personality types in common. 132 that have 3 of the personality types in common, and so on. All right, now I added those numbers up. So I wanted to find out what was the total sample size, and I got 375. Maybe I need that, maybe I don't. Well, right away, I think I'm going to need it. Part A, use the data to estimate the probability that they will have 0, 1, 2, 3, or 4 preferences in common. Okay, enter your answers to 2 decimal places. All right, so what about 0? All right, I'm going to write it this way. I'm going to do this. What's the probability of 0? All right, that's going to be none, right? That's none. That's this one right here. So none, we had 31 people out of 375. Remember how it goes? It's the number of elements in the event divided by the number of elements in the sample space. So this is going to be 31 out of 375. Let's turn it to a decimal. And I got 0.0826 ... If I round it off to 2 places, I'm going to write this as 0.08. Right, or maybe 0.08. What's the probability of having 1 in common? Well, 1, all right, now I'm up here. I see 1 trait in common. There's 61 people out of our 375. So this is going to be 61 out of 375. My calculator, 61 divided by 375, I got this. I got 0.162666. If I just round off to 2, I'm going to get 0.16, 0.16. Okay, I'll fill the rest of them in so you don't have to watch me do all that. But you can see what I'm doing here. I'm just making a division. So I just computed the rest of these. So what do we have for 2? For 2, I got 117, right? 117 divided by 375 is 0.31. So that's 0.31. For 3, all right, for 3, I got 132 divided by 375. Now that came out to 352. If I round to 2 decimal places, in statistics, we round, okay, to 2 decimal places. Oh, why did I write 36? This is going to be 35, all right? Round to 2 decimal places, I'm just going to get 0.35. All right, so that's going to be 0.35. And then at 4, I got 34 divided by 375. I got 0.09. Now, question B, this is interesting because it says, do the probabilities add up to 1? I'm going to claim no because we rounded off, right? We rounded things off, so I don't expect to get 1. However, I know what's supposed to happen here. If we took these decimals, right, you write a decimal. If we wrote it all the way out, right, every one of these decimals all the way out, they cover the entire sample space, so they're supposed to add to 1. But if you do this on your calculator, you get about 0.99. And they don't add up to 1 because we rounded off. But we're going to say yes because they do not cover, no. Yes, because they cover the entire sample space. That's what the problem has in mind. So theoretically, they all should add up to 1. And the last part, what is the sample space in this problem? Well, the sample space is a set of all possible outcomes. So what could you get? How many preference types could you have in common? Well, you could have 0, 1, 2, 3, or 4. Okay, 0 doesn't include 4. That's no good. That doesn't include 0. Where's the 5? That makes no sense. How about this one? What are the possibilities? 0, 1, 2, 3, 4. All right, there we go. That is the sample space to this problem.